Hi there. Okay, so we are going to now draw a connection between what you did in week 6 and what you're going to do in week 7. So I'm going to start by reviewing what we covered in week 6. And I'm going to start by looking at this particular question, which is a cereal company question. So this company has two of the ingredients, oats and rice, which provide vitamins A and B. And so far, I already know my x1, x2, but you're going to keep reading and you're going to look for your x1, x2 by making a connection here. You see where it says an ounce of oats costs 0.06 and an ounce of rice costs 0.03. And we're going to minimize cost. This is another thing that is being stated. You're also told that you are limited to 13 milligrams of vitamin B and 45 milligrams of vitamin A. So now you know those are your constraints. So quite simply, we know that we can label X1. We can say X1 is going to be the oats. We know that X2 is the rice. We also know that our objective function is to minimize, because it's stated in a question, where we're going to have 0.06 oats, which is x1, plus 0.03 of the rice, which is your x2. Okay, so that helps us there. Now our constraints. So the constraints are the vitamin A. So we know we have vitamin A and vitamin B. And if you recall, the easiest way to set this up is so that you have your two variables, x1 and x2, or however many you may have across the top. And sort of think of this as how you're going to start to set up your equation. So for example, as you read, you'll see here, it says the company wants to know how many ounces of oats and rice it should include in each box to meet the minimum requirement of 45 milligrams of vitamin A. So I know that this is less than or equal to 45 milligrams of vitamin A. And same thing, 13 milligrams of vitamin B while minimizing cost. It says here an ounce of oats. So oats is our X1. An ounce of oats contributes 10 milligrams of vitamin A and 2 milligrams of vitamin B, whereas an ounce of rice contributes 6 milligrams of vitamin A and 3 milligrams of vitamin B. Obviously, this is a non-negative, which means that X1 and X2 respectively will be greater than or equal to 0, meaning that we're in the first quadrant. So, in your particular homework last week, what we did was we converted our x2s to y's. So instead of calling this x2, we converted these to y's and we solved for the y and we graphed it. So, for example, for vitamin A, you would have 10x1 plus 6y is less than or equal to 45. You would have subtracted the 10x, so you subtract 10x and 1 here and here. Alright, and then we rewrite this because we always like to have the variable in the front part of the equation. So we have 6y is less than or equal to negative 10x plus 45. And then we divide by 6 to get the y by itself. This brings us, or gives us the equation where y1 is less than or equal to negative 5 over 3x1. 45 and 6, these both can be reduced by 3. So if I were to divide this by 3, or 45 by 3, I would have 15 over 2. Okay, and so now I have the first equation. This is for vitamin A. I would do the same thing for vitamin B. For vitamin B, I would take the equation where we have 2x1 plus 3y is less than or equal to 13. I'm not going to worry about the units. I'm going to subtract the 2x on both sides, 2x1, 2x, same thing, to get 3y is less than or equal to negative 2x plus 13, and then I'm going to divide by 3 on all three terms. Canceling this out, leaving me a new equation where I have y2 less than or equal to negative 2/3 x1, or just x, plus 13 over 3. And then obviously we will go to rentcalculators.org and we would graph these two equations. So let's go ahead and do that. And this is just to recap what we did last week. And put everything in perspective and how this connects to what you're doing this week. So here we are. I'm going to go ahead, I'm going to drop in my first equation, which is less than or equal, less than or equal to, so we're going to go here, this one. Alright, and I'm going to put in parentheses, negative 5 over 3 x. Actually, let me do close parentheses there. And then plus parentheses at 15 over 2. Alright, and then this should graph. Let's see if it actually likes this format. No. See, the reason it's doing that is because I did not put the times here. So you have to be careful and see how different that looks. So put the little asterisks in between the x and the fraction. Same thing for this one. This is a less than or equal to. Alright. And you're going to do the same thing. You're going to put in your fraction. So we're going to put in negative 2/3. Alright, so negative 2/3. We'll do the asterisk x plus parentheses 13 over 3. And we will graph that as well. Okay, and here is our overlap. We have 3 points. We have, it looks like the point 0, 4, 4 1/3. 0, 4 1/3 is one of them. We have 0, 0. We have this intersection here, which we need to look up. And we have this point here, which is crossing the x-axis. This looks like 4.5. We could test it. We can put a 0.5 on this one and see what happens. Let's see. So yes, definitely. So we could check the intersection for this. And let's see, click on both of these. And that's one of our intersection points. Our intersection point is this one right here. And for this one, like I said, this could be potentially 4.5 or a point very close to that. Okay? So this is what you did in week 6. What you're going to do in this week is you're going to actually use Excel, and I'm going to send you a template similar to this so you can work it through. And technically with this video you should be able to program this fairly easily. So first thing we do is we set the template up where we look at this is a product. It's a minimization. Our x1 we can label oats. Our x2 we're going to label rice. Okay. We also know that the cost per unit in this case is, we go back to our model, we have 0.06 for the oats and 0.03 for the rice. So we'll bring that value here. Okay. Now, as far as the vitamins, this is vitamin A, so we're going to put vitamin A. And this is vitamin B. And what we know is that for oats, when we look at oats, we need 10 milligrams of vitamin A versus 6 for the rice, and 2 milligrams of vitamin B for oats versus the rice where you have 3. Further, you're going to look at this constraint, and we're looking at what's available. Now, if you recall in the question, we had 45 milligrams available of vitamin A, so we're going to meet this minimum requirement, and 13 of, in this case, vitamin B. The other setup involves the objective function, decision variables, and the constraints. So what you're going to notice is in blue, and I'm leaving you this template. Remember, x1 is our oats, so we're going to put oats here. And then x2, we're going to put in our rice. Okay, your objective function is basically a formula, which is, I'm going to highlight these up here, and if you notice, it's oats times how many of that particular decision variable we use, times the cost for rice, which is B11, D4 times B11, which is the amount that I'm going to use. So you're going to input that formula where it says profit and hit enter, because you're basically saying, okay, if I multiply this value times this value plus this value times this value, I get my objective function. For usage, again, this goes back to how much of this I'm going to use. If I haven't made anything yet, then I'm under each of these respectively. So you notice I'm negative. Alright, and so as I make these, I will start to go over, eventually hit even, become even, which will make these zeros. And, you know, obviously at some point I'll go over that amount. The way this works is I'm multiplying again the amount times the B6 and C6, the B10 times C6 and B6. So I'm multiplying across for both of these. So each of these respectively, this is all about vitamin A in the row 6. This is all about vitamin B in row 7. So when you look at the equation for usage, the equation for usage will say how much of this are you using, and then multiply it times the value for each of the constraints. So in this case, B10 times C7, and then B11 times B7, because that's relating back to the oats and rice versus the quantities of oats and rice versus as a sum, am I going to exceed that required minimum? The other technical thing that you will have to do here is you will have to go to File, Options, Add-ins, then you're going to go to Solver Add-in and you're going to hit OK. When you do that, you just have to go to Solver Add-in and click on that and hit OK. Once you do that, you go to Data and check for the Solver button here, which should be highlighted. And this is where the magic begins, because now you're going to select the following. The B12 is where your objective function formula sits. This is a minimization, so you're going to click on minimization. Notice that B10, B11 are already highlighted because that's these two blue cells. You don't put numbers in there unless you are guessing yourself. If in the case that you are not guessing, then you just want to put these in here and make sure that they're zeroed out. Your constraints. when you click on the constraint, you notice that this says E6 has to be greater than or equal to G. This is a minimum, the minimum requirement of 45, which means that I want this number in here to be 45 or greater, and I want this number in here to be 13 or greater, hence why both of these are set as such. If you ever need to change or add, literally just click on change or add. So if I want to change this, I will click on change. If I want to add, I will just click add. You want to click also or check off that you want the non-negative. Understand this is a simplex linear programming. And then after that, all you have to do is hit OK. Okay, this you can ignore this. This is just my computer being stubborn. There's my answer. So according to this, now mind you, I wrote profit in here. This meaning that this is the least amount of cost that I would have. And the least amount of cost would be for me to make 4.5 worth of oats, which would cost me about 27 cents. And I would actually meet the requirements. Now you notice that this, however, did not exceed the 13. This is telling me that there's potentially a better solution. Let's run that one more time and see if it changes, because sometimes this computer system can be quirky. Okay, see there. This is giving me all the different decisions. So you saw how that changed several times. And as I hit continue, I can get even sensitivity report. I could get the limits. Let's run the sensitivity report and I'll look at that with you. This looks like the better decision because I've exceeded. See how these are both positive, and I want that. It looks like 23 cents and 7.5 ounces of rice and no oats in this case. If I look at the sensitivity report, this tells me the allowable increase or decrease. It gives me the coefficient values, which obviously we already knew. And it also gives you final values in terms of what's available. Here's your shadow price, which is 0.005 and 0 respectively. You have an allowable increase or decrease for both as well. So this is what you're doing this week. You're playing with these different functions and determining which or what is your optimal value. So best of luck. I will be giving you more examples as the week progresses.